Welcome to Tech Prep video tutorials. In week 5 of chemistry, let's solve a question from states of matter. The question asked is, a scientist proposed the following equation of state for a gas, which is given by P equals RT by Vm minus B by V square Vm square plus C by Vm cube, where V stands for the molar volume, where B and C are independent of temperature T. There are two factors B and C which are independent of temperature, and as specified, Vm stands for molar volume. And what we have to identify, what is the value of the temperature, volume and the compressibility factor at the critical condition, which is denoted by Tc, Vc and Zc. So let's look at the options. Now the trick with this is, when you are given any options, you don't have to arrive at all the answers. If you arrive at even one of the answers partially, come back to the answers and check, because sometimes we can identify that could be the only answer given in one of the options. So we don't have to verify or solve the complete question. However, let's proceed and see. Let's start off from the given equation, and when we start simplifying it, we arrive at this value, wherein it looks like a triadic equation which has 3 roots, and at critical condition all the values become equal to the critical values. I mean in terms of the volume, pressure and the temperature. So by taking the sum of the roots, 3 roots at a time, we will arrive at one value where Vc is represented, where critical volume cube equals to C by pressure at critical. Now let's sum 2 roots at a time and see what do we get. We arrive at equation 2, which is given by 3 times V squared at critical equals B by critical pressure. So let's divide equation 1 by equation 2. We come to the value where Vc equals 3C by B. As I said earlier, let's go back to the options. When we check it out, the value of Vc equals to 3C by B is not the ones which we are looking at given in options A and B. So options A and B are already out. So the answer could be only from options C and D. Let's proceed and see which would be the right answer. By putting the values of the critical volume in equation 2, we can arrive at the value of the pressure, which is given by B cubed by 27C square. Now let's take the sum of the roots one at a time. When we do this, we arrive at the third equation given by 3V equals to RT by P. But if you look at this can be represented in a very generic formula, where the compressibility factor equals Z equals PV by RT. It's just that it's in the reverse manner. Now let's proceed and see. So from the equation which we have arrived at, we can calculate the compressibility factor denoted by Z or Z, and when we replace the value, Zc equals 1 by 3. So we have arrived at 2 values given by Vc and Zc, which is V equals 3C by B and Z equals 1 by 3. Now if we go back to the options, we already know that A and B are out, and if we look closely, we arrive that B is the right answer to this question. We don't have to identify the other part of the option given. However, just since we are practicing, let's solve the question completely. So let's replace the values of V and P in equation 3, and so that we can arrive at the value of T, that is the temperature. So when we replace the values of P and V, we arrive at the value of T, which is equal to B square by 3RC in terms of B and C. So these are the values which we arrive at using the equation given by the scientist. So the right answer to this question, which we have already arrived at, is option D.